So page 1, some of the why. Page 2, some of the how. So one of the only things you have to learn from this lesson is that the derivative of e to the x is e to the x. So if I do question 1a, I'll come back to the stuff above there in a minute. That's a product rule question, because two things are being multiplied. The first thing is x squared. The second thing is e to the x. The derivative of x squared is still 2x. Be careful. We still use the power rule on that. We don't use the power rule on e to the x because it's not x to the power something. It's a number to the power x. It's different. We use this new rule. So the derivative here, f primed of x, is f primed times g plus g primed times f. And I'll factor that. I can factor out an x. I can factor out an e to the x. I'm left with 2 plus x. Do the same with question B, except it's quotient rule. That's f. That's g. F primed times g minus g primed times f over g squared. So let's factor, sorry, I need some space here. Let's factor x e to the x out of the top. That's x to the fourth on the bottom. I can cancel an x top and bottom and make it e to the x, x minus 2 over x to the power 3. Okay. Now this next question, question C, the textbook says this is a new rule to learn. They say if you're taking the derivative of an exponential function and the exponent is not x, use this rule. But you already know this rule. This rule is the chain rule. Replace this new function with u. The derivative of this is e to the u. The derivative of this is g primed. And then you multiply them to make dy dx. So question C here. If I was going to go through all the steps, I would replace this 3x with u. U is 3x. If I take the derivative of this first function, I get dy by du, and it's its own derivative. And if I take the derivative of the second thing, that's 3, and then I multiply those things. I'm going to move the 3 to the front. Okay. I don't do all that work when I do the chain rule on this function. I say, I see y is e to the power u. So I differentiate y to the power u, and I leave the inside alone, and then I differentiate the 3x, and I get the same answer. So I think it messes with people because it's not an inside function the way we're used to. So, but this is the same rule as the chain rule, right? You know you know if you take the derivative of x to the power 4, you get 4x to the power 3. And you know now that the derivative of e to the x is e to the x. Well, if I replace the x in that first function with x squared plus 1, then this is x squared plus 1 here times 2x. And if I go e to the x and I replace the x with e to the x squared plus 1, then the derivative of that is e to the x squared plus 1 times 2x. It's the chain rule in both cases. It looks different because we write polynomials and exponential functions differently, but it's the same rule. So question D, I'm going to do it the fast way first, and I think you can probably do it the fast way too. And go, the derivative of this is e to the u times the derivative of u. I'll come back later when I'm not recording the video and do it with all the steps. But I wouldn't expect you to show the steps. Differentiate e to the x, get e to the x, derivative of the function that is replacing x. That's chain rule. You should know how to do this next question, so you could try it ahead of me and check your answer, or you can do it with me. First, I'm going to find the point. I'm going to say f of 1 is 3 at, negative 1, e to the negative 1 squared, and that's 3e. That's a decimal. You could get the decimal out of your calculator. I'm not going to. So the point is negative 1 for the x value, 3e for the y value. I'll go find a calculator later, and I'll fill in the decimal answers as well. But the 3e, it's just like 4 pi. It's a number. It's a decimal. The derivative is 3e to the u times du dx. The slope at negative 1 is negative 6 times negative 1 times e to the negative 1 squared is 6e. Y equals mx plus b. The y value is 3e. The slope is 6e. The y value is negative 1. Am I right? If I'm wrong, I'll fix it later. And there's the equation of the tangent.